So for this question, we're given a little bit less information than we had in the previous example. The only information that I have is my initial concentration of the weak acid. For this particular example, we're looking at methanoic acid. So the formula for methanoic acid is HCOOH. And when it reacts with water, okay, we transfer a hydrogen. So we're left with HCOO and hydronium. If we fill this into our ice table, it's balanced at a 1-to-1. And they're asking us to predict the hydronium ion concentration and the pH. So once I know this value here, I can use that to find pH. All that we're given is the initial for the acid. So the initial is 0.200. Okay, I don't need to include water in my ice table. And initially, before the reaction, these are going to start at 0. So because I don't have any information about the values at equilibrium, I can assume that these are both going to increase, and it'll be by X amount. So at the end, I'll have X mole per liter and X mole per liter. The amount that these products increase by is going to be the same amount that our weak acid decreases by. So this will be minus X. So we'll have 0.200 minus X. Now, if we were to sub this into our equilibrium expression as is, we would have Ka equals X squared, because I have X times X for the product, over 0.200 minus X. This is going to make for some pretty complex math. So this is where we look at the rule of 1,000. The rule of 1,000 is take the concentration of your acid and divide by Ka. If it's bigger than 1,000, we can ignore this X value. So the concentration of the acid in this case is 0.200. And the Ka value for methanoic acid, so if we refer to our data book, methanoic acid, also known as formic acid, has a Ka value of 1.8 times 10 to the minus 4. So if we substitute that in, 1.8 times 10 to the minus 4, and we're going to get an answer that is much greater than 1,000. So if you sub that into your calculator, we get an answer way bigger than 1,000. So the rule of 1,000 applies, which means that we can get rid of that minus X and make the math a whole lot simpler for us. So for weak acids, typically the concentration initially is the same as the concentration at equilibrium. Because there is such little change, we just assume that it's the same value. So now I'll sub in my Ka. So Ka is equal to 1.8 times 10 to the minus 4. This equals X squared over 0.200. And now we just need to solve for X. I would start by multiplying both sides by 0.2 to cancel this out, and times this by 0.2. So I end up with 0.00036 equals X squared. Take the square root of both sides to solve for X, and we get X equals 0.006. Go back to your ice table. Okay, X is the value of hydronium at equilibrium. So hydronium equals 0.006 mole per liter. And if we use that to find pH, we can take negative log of our concentration, which will give us a pH of 2.22.